All righty. All right. No, you don't. Just draw it. Just make this 16, and just make sure this is a 90-degree angle. All right. So, notice our reference sheet from yesterday. The area of a triangle is 1/2 base times height. That's what I'm going to use. That's the area form I'm going to use for this one. So go ahead and write it down with me. Area 1/2 base times the height. Now, we actually don't know the base, the total base of this triangle, because the base goes from here all the way to over here. The 16 is only going from here to where the 90-degree angle is right there. So for now, go ahead and put 4. We could use Pythagorean theorem, but right now this is going to be 4. So from this, where the 16 ends to the end of the triangle, let's just go put 4 for now. There was a method of finding that out using Pythagorean theorem, but I'm not going to cover Pythagorean theorem right now. I don't want to go into a rabbit trail. A squared plus b squares? Yeah. We could have done that, but we'll not bother with that. Now, the base and the height are always separated by 90 degrees. Notice this 90 degree right here. That's going to separate your base and your height all the time, no matter what kind of shape it is. In other words, if I look at the reference sheet, any shape that has a height in it, like a triangle, or notice a trapezoid, look, it has height in it, or a parallelogram has height in it, they're always going to be separated by 90 degrees no matter what shape. If you have a height in the formula, then it's going to be 90 degrees with the base. So let's go back over here. Let's just plug and chug then. Area then is 1/2. The base is going to be 4 plus 16, the whole bottom side. That's going to be 20. The height, well, that's 90 degrees with the base. In this case, it's going to be 12. Nice. So I got the area then, 1/2 times 20. Let's see. 1/2 times 20, that's the same as taking a number and dividing it by 2. So it's really 20 divided by 2, which is going to be 10. And then 10 times 12. Phone's away right now, Sedano. Thank you. I got the floor. So the area then, watch this, is going to be 120, in this case, square units. If all these measurements were feet, then it'd be square feet. If all these measurements were inches, then it'd be square inches. But in this case, it's just a generic term, square units. Rocking and rolling. So that's how many units fit inside the triangle, just like we did on warm-up, but the squares that fit inside. Perimeter, though, on the other hand, I want you to think of this when we do perimeter. Watch. Let's see. Watch this guy.
Hi, welcome to Math Antics. In this lesson, we're going to learn about an important concept in geometry.
So it's kind of a silly example, but I like the picture that he gives of perimeter, and I want you to remember this little cartoon picture whenever we discuss perimeter. Watch.
Called perimeter. Perimeter is just a fancy math term that means the distance or length around a shape. But what exactly does the distance around a shape mean? Well, distance or length is a one-dimensional quantity that we can measure with units like centimeters, inches, or miles. That means that perimeter is also a one-dimensional quantity that we can measure with units of length. For example, the perimeter of a shape wouldn't be just 10, but it could be 10 centimeters. Or instead of being just 25, it could be 25 miles. The units are really important when you're talking about perimeter. Okay, but what exactly do we mean by around a shape? Seems like there would be a lot of different ways to go around a shape. Some of them would be short, and some of them would be very long. Well, perimeter means the absolute shortest distance possible around a shape. That would be the distance you'd get if you trace the path exactly around the border or edge of a shape. A good way to see what perimeter is to imagine that you could walk right along the edge of a shape, like this 5-sided polygon.
This is what I want you to imagine now.
Imagine starting at one of the polygon's vertices and then walking along each side until you got all the way back to the point that you started from.
That's perimeter.
The total distance you traveled would be the perimeter of that shape.
No matter what the shape is.
In this case,
it's just around
if the length of each side of the polygon was 10 meters, the total length you would travel along all 5 sides would add up to 50 meters. Another good way to see what perimeter is to imagine that you could take a shape, like this square, and break it at one of its...
So that's perimeter. Coming back over here then, let's find the perimeter for example 3. The area is a square units that fit inside it. Perimeter is around. So let's see the perimeter then, I'm going to put in red here. The perimeter then, imagine that little guy, that cartoon guy you just saw walking around the triangle. How much would he walk? Well, he'll walk 20 plus 20 more. Thank you. That's the perimeter. In this case, this is going to be normal units, not square units, because I'm not counting the amount of squares, Diaz. It's just the units around. So let's see, 40. So that'll be 53 units. Question, example 3. One more example though, Hernandez. I love the eagerness to get started though. Wow, that's pretty breathtaking. Whew. Wow. Guy's on fire. Question on example 3. Questions. Let's try example 4 then. Here we go. Go ahead, example 4. We got a circle going. Go ahead and draw a circle with a diameter of 14. Right, so here we're going to find the area and circumference. Now, the circumference is just a fancy schmancy word for the perimeter of a circle. Since a circle is not made up of straight lines, just pure curve, we call the outside not the perimeter, but the circumference. So circumference is only specific to circles. It's the perimeter of a circle, but it's not made up of straight lines, hence the word circumference. So we're going to write area and circumference. Let's find it. All right, area formula. Let me look at my formula table that I gave you. Area of a circle. Here we go. A is equal to pi times the radius squared. So pi for us, if you want to put on your reference sheet, go and put pi is approximately 3.14, just to the nearest hundredth. There's actually an infinite decimal. But for now, if you want to put that on your reference sheet, go ahead and do that. That'd be wise if you tend to forget what pi is, Diaz. Pi is approximately 3.14. So let's use this formula, pi r squared. Area equals pi times the radius squared. So we're going to figure out how many square units inside the circle. So here we go. Area then is equal to 3.14. Do you guys remember the difference between the radius and the diameter of a circle from way back in the day? Nice. Radius is half a diameter, in other words. Half the diameter.